We're going to look at one of the simplest examples of gravimetric analysis. Now, gravimetric analysis is always an analysis system where we're analyzing some compound. Often, that compound might be a powder. Whatever form it is in, we call that the analyte. If it's a powder, we dissolve it in water. It might already be in solution as already dissolved in water, but it has to completely dissolve in water. That's one of the assumptions we have to make. We have to be a little bit familiar with the chemistry system when we're designing these kind of analytical processes. So we react it now with something that will form all of the compound we're interested in into a precipitate. So often we are mixing something with a chloride or sulfate that make it insoluble in water, and all of the stuff we want to analyze that's dissolved in the water turns into a precipitate. Now we get rid of all of the other things that are in the solution still. We wash the precipitate and we dry it, and then we find its mass. Then we start the analysis that often has to do with stoichiometry. And so we find information about the analyte. We find information about this original sample that was dissolved in water by calculating something from the precipitate. So we take this precipitate, and depending on how much there is, it tells us something about the analyte. And there are lots of different kinds of gravimetric analysis problems that you should anticipate being able to solve, but they're all about the stoichiometry. So here's an example of a problem. We have an analyte, a sample. The total mass of this sample is 25 grams. It's just some kind of white powder, a mixture of things. We know that one of the compounds in that powder that we're interested in is sodium sulfate. So we're going to dissolve this 25 grams of powder. We're going to treat it with barium chloride. And when we treat it with barium chloride, in this particular problem, we're going to be making barium sulfate. The barium and we're going to be making barium sulfate because the barium is going to combine with the sulfate and make a relatively insoluble precipitate. That barium sulfate we're then going to wash and dry and find its mass. Now in this particular problem, the mass comes out to be 5.342 grams of precipitate. Now we're going to take this information that we've just found out about the precipitate, and we're going to answer a question about the analyte. The question here is find the grams of sodium sulfate in this original sample. So let's take a quick look at that. So we have this chemical equation, and we've left out some of the spectator ions just to make this, exactly about the chemicals that are reacting. The sulfate from the sodium sulfate is going to react with the barium from the barium chloride. We mixed those two things together, and we got barium sulfate, and we washed it to get rid of all the spectator ions. We dried it to get rid of all the water. And we know now that the mass of our precipitate is 5.342 grams. Remember, our question was to find the original mass of the sodium sulfate that was in our sample. We know that in our equation, for every sulfate that ended up here, we had 1 mole. For every 1 mole of sulfate that ends up here, we had 1 mole of sodium sulfate in our original sample. So this number of moles of the sulfate is going to be the same, a 1-to-1 ratio, as the moles of sodium sulfate that was in our original analyte. So we're now we need to convert this moles of sodium sulfate in our original analyte to grams of sodium sulfate in our original analyte. So we find the molar mass of sodium sulfate, and we do our calculation. We get 4.1024 grams of sodium sulfate. Now I'm going to go back and look at my original problem, and you remember there was 25.0 grams in our original sample, so we had 3 significant digits. We're going to put our answer here in 3 significant digits. So that's the answer to the first question. This is the grams of sodium sulfate in the original mixture that we were analyzing. Now, a couple other problems we might anticipate seeing here would be maybe this. In our original sample, what is the percentage of sodium sulfate? We know that there's a bunch of other stuff, but we're really interested in sodium sulfate in this problem. So what is the percentage of sodium sulfate in the original sample? So we know there was 4.10 grams out of 25, and so we can find the percentage. Relatively simple problem once you've already calculated grams of sodium sulfate in the analyte. Or another common kind of problem is maybe we're really interested in one particular ion in the analyte. So here this question says, how many grams of the sulfate ion are in the original sample? And so remember, we had 0.02888 moles, and we can just multiply that by the molar mass of the sulfate ion to get the grams of the sulfate ion in that original sample. So remember, we were taking a look at a simple gravimetric analysis problem, and there are a lot of more complicated examples, but I hope this was helpful to get you started with gravimetric